Welcome back, please. This is Stephen Levy again, and I had a longer introduction plan, but we're pressed for time. But I don't think our guest needs much of an introduction. He's Vinton Cerf, one of the founding fathers of the internet, inventor, co-designer of the TCP/IP protocols. He's currently the vice president and chief internet evangelist at Google. He's coming to us via Skype. It's worth $8 billion to Microsoft to get him on here. Please welcome Vinton Cerf.
Hi, Steve.
There he is.
Can you hear me all right?
Hi, Vin. How are you?
Well, I'm sitting out in Los Angeles, so I'm sorry that I couldn't be there in person with you, so this will have to do.
Okay, well, we're delighted to have you there. First, one question before we start looking forward. You were there at the beginning there. Knowing then what you know now, let's say if you know then what you know now, would you and your fellow designers of the architecture of the internet done anything differently?
Well, let's see. First of all, it's one thing to know that you should have done something differently. It's something else to know whether you could have done it differently. So I'll tell you what I would have done if I could. One of them would have been to choose a much larger address space so we wouldn't have to go through this IPv4 to IPv6 introduction, which is painful but happening. As you know, June 8th, we did a worldwide IPv6 day, but it would be nice not to have to do that. And second, I would have built more into the system for security and authenticity, authentication of users, authentication of the devices in the net. But the technology to do that wasn't developed until after we had standardized the 1978 versions of the protocols, which is largely what you're using today.
Mm-hmm. Do you think that now we have the tools to provide the security that we're striving to achieve there? We just had a little discussion about this on stage a few minutes ago.
So the answer is yes, I do. I don't think that we necessarily can do everything that we want, but we can do a great deal more than we have in the past. We can do good, strong authentication. We can use two-factor authentication. We can check for false IP addresses as they enter into the network. We can secure the domain name system. We can secure the routing system by using RPKI. There are a whole series of things that we could do now with available technology, but it takes agreement for people to do that. And on top of this, Steve, there's more than just technology. We have to come to some common agreements on an international basis about what, for example, does a digital signature mean? What legal weight does it have? What do we do about malfeasance on the network? Do we have a recourse when an attacker is in one country and the victim is in another? That's going to take some multilateral agreements on the legal side, which are not yet in place.
So you mentioned a few challenges there. Which one do you think are the biggest threat to the net as we see it now?
I think probably the biggest threats have to do with the introduction of worms and viruses, and Trojan horses, and things of that sort. Direct attacks, subtle attacks, the spear phishing, for example, which catches people unawares because in some ways they are overly naive about the email that they receive, things like that. Now, we can attack those problems, for example, by using strongly authenticated origins, so we could verify where does an email come from. You can refuse to interact with a party unless you have a strong indication that the party is who they say they are. So there are things along those lines that I think are the toughest to deal with, to say nothing of coming to multilateral agreements about law enforcement, in which all parties are treated both fairly but effectively.
Mm-hmm. So let's talk about Kansas City for a minute. Google has this project going on there. They wanted to select a community in the United States to provide ultra-high-speed broadband at a reasonable price. Is that correct? They chose Kansas City, Kansas. Now they're going to do it in Missouri as well there. What's the point of that? Is this a proof of concept? Does Google want to get into the internet provider business?
So first of all, Milo Medin, who has had a long history with both the internet and with cable communications and the like, is leading that project. Our purpose is not to get into this as a business necessarily. It's to both demonstrate what happens when you have gigabit speeds available. Some pretty dramatic applications are possible that would be less attractive at lower data rates. But second, in order to verify and to illustrate what the actual costs are for implementing and operating systems of this kind. It's my hope and expectation that we will share what we learn with others. Ultimately, I would imagine that this network will be remanded to another party for operations, but I don't know that for certain.
Mm-hmm. What kinds of innovations do you expect to see arising from it?
Well, one very obvious thing is that when you're dealing with video, and of course we deal with a lot of it through YouTube, that when you're watching video today, streaming is a very common practice. When you're operating at gigabit speeds, you can actually deliver a video file faster than you can watch it. And so rather than pushing the bits out in a synchronous way, that is to say, so that speech and video are carefully synchronized and that the video and audio don't break up because you deliver packets at exactly the right time. Instead, you could literally download the hour's worth of video in about 15 seconds and then watch it at your leisure. So it actually puts less stress on the network to have the higher speed of operation. After that, who knows? People will invariably find new ways of using capacity that you never thought of once you supply it.
So I know you've been a strong advocate of net neutrality in your role at Google. Can you explain us where we are now in light of the FCC's the decision to go with it in a way that seems to have something to displease everyone almost, but give something to net neutrality, and where Google is in light of its agreement with Verizon to sort of separate out the definition of net neutrality between the mobile world and the landline world.
So let me start out by saying that the FCC, as you know, has postulated a set of neutrality mechanisms, and we hope that they'll be able to enforce that. But as you could see from one court case, there may need to be legislation to give them additional leverage. Second, with regard to the proposal that came from Google and Verizon, this was really a homework assignment. The question was, given two parties who were very far apart, how close could they get in terms of any kind of recommendation? The purpose behind that document was to inject ideas into a legislative process. It was not an agreement between Google and Verizon. It was not a deal. It was simply text to be considered in a legislative process. The fact is that we couldn't come to an agreement about what to do about wireless. And since we couldn't come to an agreement about what to do, we didn't say anything in that particular document. I think many people believe that we should see these as all common assets and that we should be equally neutral about their our ability to access those assets. But I think it's still fair to say that there is less capacity in the highly contentious wireless environment, and therefore one has to be more thoughtful about its management. But beyond that, I hope that there will be I hope that access to broadband in all of its forms, wired and wireless, will be equally accessible to everyone. And I use the term equal with some care here. We understand that some people have more capacity because they paid for more. Some people will have less. That we don't object to. We understand the need for network management. We simply don't want the access to the broadband channels, whether wired or wireless, to be used in an anti-competitive way. And I think that's the intent of the FCC language. That's certainly our hope as well.
So I want you to explain a term I've heard attributed to you, the interplanetary internet. What is that? What does it mean? And when will we have it?
Okay, I was waiting for you to say, and are you out of your gourd? So this was actually a project started at the Jet Propulsion Laboratory in 1998. We said, up till then, most of the communications for space exploration had been accomplished with point-to-point radio links. And we thought, what would happen if we had a rich networking environment in which to support both manned and robotic exploration? So we took off and said, well, what would it take to build an interplanetary internet? And in the end, we discovered that we couldn't use the standard TCP/IP protocols because the round-trip times are too big. Flow control with TCP with a 40-minute round-trip time just doesn't work. So we had to invent a whole new suite of protocols that we called delay and disruption tolerant networking that deals with the long delays and also with the disruption caused by planetary motion. We've implemented the protocols. They're on board the space station. They're on board an epoxy spacecraft that just rendezvoused with a comet, Hartley 2, in November last year. We're standardizing the protocols with the Consultative Committee on Space Data Systems, and we're hoping now that these protocols will be adopted by all the spacefaring nations so that all of our spacecraft will be able to communicate with each other in a standard way, just like when you plug your computer into the internet, you can talk to 1 billion or so other machines because of the standards. So we're actually quite far along in terms of the technical capability to operate networks in space.
Wow. So we have the interplanetary internet. That's awesome. One final question. You mentioned IPv6. You know, I take it those tests we had were positive. So are we now on a collision course with the Internet of Things?
Well, I don't know if I would call it a collision course. I've been quite excited with the idea of
a nice collision.
Lots and lots of appliances on the network means that they can be managed through that network, and it means opportunities for third parties. For example, if you put all of your entertainment equipment on the net, suitably access controlled, of course, and then you turn over the responsibility for managing all of your entertainment to a third party, you could just go to a nice little web page and say, I want these movies and this music, put this on the iPod, put this in the car, put this on the DVR at home, and download these other things on my laptop. All of that stuff can be managed. Now, my house is fully wired for sensor networks using IPv6 in a wireless mode, and they're reporting the state of the house every 5 minutes to a server downstairs, and twice a day I get a summary report of how things are doing in the wine cellar. So the fact is that we're going to see lots and lots of these sorts of automated appliances and houses that are fully sensor networked becoming a part of the normal environment, and I'm quite excited about what you can do with that.
Great. Well, Vin, I know we can go on for a long time, but you have to run here. We at all Tribeca are very happy that you're on our planet. Thank you so much for sharing some time with us.
Thanks so much. Bye-bye, Steve. I appreciate it.
Bye-bye.
Yeah.